And so we need to talk about Ethernet for just a minute. There was a time when there were 3 competing network standards. There was something called ArcNet, there was Token Ring, there was Ethernet. All 3 competing technologies, all very different. And so Ethernet won, and ArcNet disappeared, and Token Ring disappeared, and so Ethernet was the one more popular. And so when we talk about Ethernet, we tend to talk in terms of speeds these days. You don't have to talk about do you want Ethernet or not. It is ubiquitous, it is the standard, it's what every computer network uses to connect devices together. And so Ethernet simply has just come now down to a discussion of speed. And so we measure Ethernet speed in megabits per second, Mbps or MB/s you may see. And it refers just to network speed. And so today, desktop computers and desktop systems tend to run at 100 megabits per second, the most common speed, Ethernet speed for the desktop system. Now, Ethernet operates at layers 1 and 2. Okay, remember? We've talked about that postman, the postal deliverer. And so how he sort of functions at the level of managing what's actually written on the letter and managing that package of information, but also he has to have the feet in the bag and the ability to get where he's going to go. And so Ethernet does that. It's managing bits, just getting bits from point A to point B, but it's also involved a little bit in the frame and making sure the frame is whole. And so Ethernet operates at 10 megabits per second, 100 megabits per second, 1,000 megabits per second. Now, it started off at 10. The first iteration of Ethernet was 10 megabits per second, and originally it was called 10 base T. It's just a little phrase you may see, 10 megabits per second, baseband technology, twisted pair wiring, which we'll get to. 10 base T was 10 megabits. But along comes 100 megabits, right? There's always the need for speed. We always need our networks to run faster than they did before. And so along comes a 100 megabits per second version of Ethernet. It was so screaming fast, they called it fast Ethernet. If you ever see that term, fast Ethernet, it's referring to 100 megabits per second Ethernet. And so for a while there, it was called 10/100 base T because it was in transition. Lots and lots of 10 megabit per second devices that are now running on a network that's capable of 100 megabits. And so it had to be backward compatible, so to speak, and it was accommodating 10 megabit devices and 100 megabit devices at the same time. Now, for the most part, these days, 10 megabit per device is gone. And so most devices today will run at 100 megabits per second. Now, that's 100, fast Ethernet. Of course, give me more speed, times 10 gigabit Ethernet. Gigabit is 1,000 megabits per second. Very, very fast. And you'll see there's some reasons to have gigabit Ethernet, probably not so much at the desktop, but on what's called the backbone network. We'll come to that. And of course, give me more speed. Now there's a 10 gig Ethernet. Very, very fast for very special applications. Maybe we'll talk about some of those later. Ethernet runs on unshielded twisted pair, UTP, unshielded twisted pair. And so that's a UTP cable. I've just sort of split it open here. There's the connector, RJ45, if you're interested, that's what that's called. And here are 4 copper wires, twisted in pairs. There's a green pair, orange pair, blue pair, brown pair. And so that's unshielded twisted pair, and that's the primary transport mechanism for Ethernet. Now, it's copper. It's unshielded. That means that it doesn't have an electrical shield around the wires that protects it from all sorts of interferences. It's unshielded. And so as a result, that UTP cable has its limitations. And the primary limitation of UTP is its length. You can never have a UTP cable from one connector, the end device, all the way back to where it's plugged into the network. That wire can never exceed more than 100 meters of cable. Now, it's not magic, not a magic number. It fails at 101 and works at 99. It has all sorts of things to do with what that cable encounters between the end device and the switching device. And so unshielded twisted pair, though, and as a general rule, can only be 100 meters. So you may think, well, golly, how do we get around that? Excuse me. And the way we get around that is with fiber optic. Fiber optic cable is not electrical. It doesn't use copper. It uses light pipe, basically. And we've sort of seen what fiber optic does. It's a very fine, clear glass pipe, more like plastic because it's somewhat flexible. And so we have this end, and it communicates, instead of using electricity, it communicates using light. Electricity, voltage is either on or it's off, 1 or 0. Light is either on or off, 1 or 0. And so you can see, but the difference here is that we can get much faster bandwidths, much faster speeds with fiber optic, and much longer distances. So if you have to run Ethernet longer than 100 meters, then you may want to use fiber. Now, I'll warn you, fiber can be expensive. It's expensive to run. It's very expensive just to put that end on this thing. You actually have to polish the end of the light band here in order to make it work. Imagine polishing the end of one of your hairs. Very difficult. And so don't take this thing for granted. It can be a little troublesome and a little expensive, but it does give you options that UTP does not.